welcome to PSCAD tutorial. In this tutorial we will see the modeling of distance relay. So if you are watching my video first time, then I will recommend you to see my previous video, and for that the link is given in the description below. So we will start. We have done some modification in the modeling of the transmission line. Here we have a series compensation block here. I removed this because for this series compensation the conventional distance relay will not work. So this is the model, and I add one transmission line for zone 2 and zone 3 protection. So this is the modeling to this is a 230 kV 50 hertz and 10 degree and the delta for this voltage source. Oh, okay, power angle delta 10 degree, and this is the transmission line. This is 100 kV total, 100 kV. This is 70 plus 30, yes, 100 kV, 100 kilometer transmission line. This is also 100 kilometer transmission line, and this source is same, but our delta here is 5 degree, and this is in this bus this load is connected. Okay, and now see the distance relay model. This is already available in the example when you install this PSCAD. Some examples are already generated with that. You can see from the examples, uh, but I have done some modification obviously for my model also. So this is the distance relay. uh, the first block is distance relay input is just VS IS, just here voltage and current at bus 1. This is the input of the distance relay. Here in the first block we calculate the phasor, here voltage phasor and the current phasor by FFT analysis. uh, in this block we can transform the ABC to positive sequence, negative sequence, zero sequence. Also you can do this by just clicking this positive, negative and zero sequence. uh, okay, then this positive sequence magnitude and phase uh, are um, bound together. uh, Positive sequence for negative sequence and zero sequence magnitude, positive sequence, zero sequence and negative sequence phasors are bound together for voltage and currents. Okay, then this positive sequence for magnitude, positive sequence phase for voltage and current, and positive sequence this is for zero sequence, I guess. Yes, this this is the uh, current, and sequence current. This is sequence current of magnitude and phase. Now this is the distance relay, where this block is available in the master library. uh, it is available in the protection tab. This is the protection. Here we need this is for line to ground fault, and this is for line to line fault. Okay, and we need the distance relay. Okay, this is more type of relay. Okay, so this is VA by IA plus K I naught. It is already mentioned in the previous video. So K is nothing but our Z0. You can see from the help also. You can see from the help that K is Z0 minus Z1 by Z1. So we need to calculate from the transmission line. This transmission line go. This is positive sequence R plus JXL. So R plus JXL. This is positive sequence Z1, and this is negative sequence Z. This R plus JXL. So just take magnitude of this Z minus this Z minus this Z divided by this Z. So you will get the value of K. So in our case the value of K is 2.65. Now this is for phase B, this is for phase C. Okay, and for line to line fault, uh, this block is used. Now we need to model the Mohs circle. These are the circle modeling of the circle. Uh, this is for zone 1, this is for zone 2, this is for zone 3. Okay, so our transmission line positive sequence transmission line impedance we can calculate from here. This plus j of this into 100 kilometer. Okay, for 100 kilometer. So this is a cosine wave generator, this is a sine wave generator, and phase frequency is 50 hertz, you all know, and this is a triangular pulse. So just we are this is a triangular uh, signal generator, but we are taking the only phase of the triangular pulse. Okay, now this two are, this is 80% of the our total resistance, and this is 80% of our total reactive impedance. So XL. Okay, and this is magnitude here R plus JXL magnitude. So root over of R square plus root of X square, we get 26.3, and this is 120 percent of the transmission line. So 1.2 into our 100% transmission line resistance, and this is 1.2 into our 100% transmission line XL, and this is R square plus X square root over, and this is 140% of the transmission line, 1.4 into 100% of transmission line R and XL. Here the magnitude is here. So R and circle and X circle, this for zone 1, this R circle 1, X circle 1, this is for zone 2, R circle 2 and X circle 2 for zone 3. So here we are taken this uh, plot for XY plot. This is for XY plot. Okay, and we are just given the R and X from here. You can see r circle, x circle, r circle 1, x circle 1, r circle 2, x circle 3, x circle 2. Okay, now for the more circle we give the radius. Obviously radius, this this is for zone 1. We given this all this, and if any fault occur in a particular uh, phase, say AG fault occurs, so this will be our 1, and this will be 1, and this will also 1 because A is involved in AB fault. So this OR gate output will be 1, and this OR gate output will be 1. Whatever the other outputs, maybe the OR gate output will always 1, because OR gate means plus operation. So here we get A, B and C phase output. Now it is going through another OR gate, so it will be 1, and from that we get the trip signal. This is a control switch. Here control switch selection value is 1. Whenever we get 1 here, this switch will connect with B, and breaker B1, this B1 will start operating. This is just we get give the control for breaker 1. In this we select the relay. Okay, we select the relay means our relay is connected with the transmission line. If we give close operation, then breaker will always close, but for protection we are connecting the relay by selecting this relay. Okay, now I am just creating AG fault here. Here this is 70 and this is 30. So our protection is our zone 1 protection is 80%. Now 70% we create a fault, so hopefully our apparent impedance seen by this distance relay will enter inside the zone 1. So this is a Z fault, and this is say 5 ohm fault impedance, and fault time is 2 seconds. Yes. Okay, just let's run it. Okay, you can see that this is the current waveform. Whenever current is increased due to fault, our trip signal is given to the circuit breaker, and circuit is open. Now we see the Morse circle. Here we can see our apparent impedance just entering inside the operating zone of zone 1, so it gives instantaneous protection. Okay, now if we create a fault just outside the, say, 90, means this will not be our zone 1 protection, this will fall under zone 2 protection, so it must be okay. Oh, it is coming inside zone 1. done a mistake, sorry for that. Actually, while modeling the circle, we have to give here the radius of the circle. So this will be half of this. So our 2.634 divided by 2, here it will be 1.317. 1.317. Okay, and this is 26.16 divided by 2, 13.08. 13.08. Now this will be 26.3 divided by 2, 13.15. 13.15. Okay, stop it. Okay, now this will be 3.951 divided by 2. This will be 1.975. 1.975, and 39.24 divided by 2, 19.62. 19.62. 39.45 divided by 2, 19.725. 19.725. For this, 4.609 divided by 2, 2.304. 2.304, and 45.78 divided by 2, 22.89. 22.89. 46.025 divided by 2, 23.012. 22.01. 23.0125. Okay, now our maximum radius is this, so you have to delete all these things. This will be our new mo, sir, mo relay. Oh, hopefully this time it will work fine. So this is 90% of the distance, 90% of the transmission line. We create a fault, AG fault. Now it should be outside the zone 1, that is zone 2. Yes, this is, oh, no, it started running. Yes, this is 90%, just after 80%. This is 90% of the transmission line. Okay, so it is coming correctly. Now if we create a fault, this block this fault, and if we create a fault, say 110%, so this is 110% means 120% up to 180 to 120% is zone 2. Mm, uh, No, one, say 25, 25, 25, and this is 75. So 120% is zone 2. We have already seen zone 2 protection. So this will fall under zone 3. So let's see it is coming or not. Oops. I just to create. Oh. Now let's see. Yes, this is under zone 3. Okay. Now I create a fault outside zone 3. So the fault should not detect. Outside zone 3 means say 50, 150%. So this apparent impedance seen by the distance relay will not come inside any of the circle. Okay. See, the apparent impedance is not inside the any of the circles, so it is outside all the zone of protection, and trip signal is on not energized. Okay, this is the way we have to build the distance relay. Actually, distance relay is already available in the example. You can just copy paste it and model according to your particular model. Okay, so this is end of this tutorial. Thank you.